So in grade 10, we learn more about our polynomials. In order to know about our polynomials, we have to tie in a lot of our information that we have done already last year in grade 9, as well as we have to take it quite a bit further. Now, just so you are aware, I'm just going to put it in writing. This unit is essential for Pre-Calc 20 and for Foundations 20. Obviously, Pre-Calc 30 and Foundations 30 as well. If you want to do anything in Pre-Calc 20, you need this unit, and you need to know it well. You need to know it very well. The good news is there's only one outcome in this, and it's talking about multiplication and factoring of polynomial expressions. Multiplying monomials, binomials, trinomials, common factors, trinomial factoring, and relating multiplication and factoring of polynomials. But the biggest thing is there's actually two main parts to it. The first part that you need to know is talking about the multiplication of polynomials. The second part is the understanding of factoring. So pay attention to your timeline, and let's get started. So our first section is going to talk about multiplying polynomials. There's only one section on multiplying because we've done quite a bit of it, or quite a bit of our work already from grade 9. Now this is the first thing. We're going to talk about distribution. Now distribution means that everything in one set of brackets gets multiplied by everything in the second set of brackets. So I talk about a few different things. Grade 9, you may have learned it this way. Set up as a chart, taking 5x and multiplying by an x and a -4, which is x fact 4. 5x multiplied by x, using our exponent laws, same base multiplying, well, you add your exponents. 5 times 1 is just going to be 5. You can only multiply things that you can actually multiply. 5 times -4 is -20. We'd just be tacking on our x. At the same time, understanding what our distribution is going to be essential, and this is how I'm going to be dealing with for the rest of this unit, and actually pretty much for the rest of your academic careers. 5x times x. Distribution means we're going to do some actual distribution. 5x times x is 5x squared. 5x multiplied by -4 is -20x. There's our answer, easy, over and done. Whereas if we look at this one, it's still not going to be anything too extreme. Let's take our -6x squared and multiply it by every single term on the inside of that bracket. So -6x squared multiplied by x squared, saying -6x to the power 4. Distributing this one, -6 by -7 is positive 42. But the x squared multiplied by the x is going to be x cubed. -6 by positive 2 is -12. And we have that x squared. The second part is not actually any more difficult. The only difference, though, is having what's known as a binomial by a binomial. So I should have probably mentioned a little bit of that. Monomial being one term, binomial being 2, trinomial being 3, polynomial being any of the 3 or more termed phrases. So if we have something like x subtract 1 multiplied by x add 3, I'm just going to show one thing by the chart just to help have a quick understanding of it. After that, I'm going to strictly show by distribution. We're going to have to take x and multiply by everything. Well, I'm going to have to take the -1 and multiply by everything. So x times by x is x squared. X multiplied by positive 3 is a positive 3x. A negative 1 multiplied by x is a negative 1x. And a negative 1 multiplied by negative 3, or negative 1 by positive 3, sorry, is negative 3. After that, we can see that we can combine some like terms. So x squared, if we have a positive 3x and a negative 1x, we would have a positive 2x. Tack on a negative 3. There's our final answer. So to show by distribution, we're going to be taking this x and multiplying it by each of our terms on the inside here. We're also going to take our negative 1 and distribute it into each term as well. X multiplied by x is still our x squared. X multiplied by 3 is a positive 3x. Negative 1 times x is a negative 1x. Negative 1 by a positive 3 is a negative 3. Final answer, after combining the like terms, is still going to be an x cubed, or x squared, sorry, adding 2x, subtracting 3. So we can continue on. 2x by x squared. This one I'll take it a little bit slower, but that 2x has to be multiplied by every single term in that second set of brackets. So this binomial by this trinomial has to be multiplied correctly. 2x by x squared is 2x cubed. 2x by negative 3x is negative 6x squared. 2x by 2 is a positive 4x. So when I take my 5 and distribute it on, I'm going to get 3 more terms. 5 times x squared is a positive 5x squared. 5 by negative 3x, negative 15x, and 5 by positive 2 is positive 10. Combine the terms that are actually like. X squared terms are like, and x terms are like. We have no other x cubed terms, so we'd have 2x cubed. But our negative 6x squared adding 5x squared is a negative 1x squared. It's not necessary to write the 1, but you can if you like. 4x's subtracting 15x's will be a negative 11x. The last thing that we need is our positive 10 because there's no other constant term. There's no other term that doesn't have a variable. And the last example on this side is what x plus y squared is. Now this is not the same, which means you can't do this. You can't say, oh, we get x squared plus y squared. Yeah, no. Our exponent laws only work for multiplication and division. This is an addition. When you have a binomial squared, you do have to treat it as a binomial squared, which means you have to actually have 2 binomials. Then we can actually properly work with it. X times x is x squared. Now x times y is a little bit trickier, but at the same time, not a huge stretch. It's just xy. If I have y times x, ideal situation, you always try and write things alphabetically. Any kind of extra number goes in the front, and then you write alphabetically. Y times x is just going to be xy, or sorry, yeah, xy. And then y times y is y squared. To finish off this question, though, we need to still combine our like terms. An xy is the same as an xy. So there are no other x squareds, but if you have one xy and you add one xy, you have 2 xy's. And finally, we have a y squared. There's our final answer. So these ones are kind of considered medium difficulty. I like trying to do a lot of this in grade 9. At the same time, if you haven't seen it, even though you should have. It's not a huge stretch. So let's go into the hard realm. It's not actually a huge difference. The biggest part is making sure you take every single term and distribute it correctly. Now I'm going to go one step at a time just so that things don't get too confusing. Negative 2x squared multiplied by 5x squared will be a negative 10 x to the power of 4. It's x squared, same base, multiplying, you add your exponents. Negative 2x squared multiplied by negative 2x would be a positive 4x cubed. Negative 2x squared multiplied by positive 1 is a negative 2x squared. The next term, I'm going to take my 4x and multiply it by each term in the second polynomial. So my 4x squared, or 4x multiplied by 5x squared, will be a 20x cubed. Distribute on further, negative 8x squared, and a 4x. Finally, I do still need to take this negative 3 and distribute it inside here. Let's go negative 3 by 5x squared will be a negative 15x squared. Negative 3 by negative 2x is a positive 6x. And negative 3 times positive 1 is negative 3. Now, I don't think I usually have to say it, but I might as well say it just because I thought about it. You do not have to take your 5x squared and multiplying by your negative 2x. They're all in the same set of brackets. You're not multiplying these, you're adding these. Sorry, I just thought I had to say it just in case. But then let's combine our like terms. Let's look at the terms that are actually the same. I see that I have a cube term there and a cube term there. I see I have a squared term there, a squared term there, and a squared term there. Finally, I see I have a 4x and a 6x. So in order to distribute and simplify, we do have to simplify, which means we have to write things. And ideally, you write things in descending order, which means you look at your exponents and write them in a decreasing order. So 4, 3, 2, 1, and this would be a 0. There are no x's, which means it actually has exponent 0. Sorry, just a little side note. Remembering anything to the power of 0 is 1. So this is actually 3 times 1, which means it still stays as 3. The negative doesn't change that fact, it still stays negative. Combine our like terms, there are no other x to the power of 4. But we do have a 4 and a 20, which is 24x cubed. Negative 2, negative 8 is negative 10, negative 25, and positive 10x, negative 3. This one is hard just because it's a lot of work. You can see that I've actually had to distribute into 9 separate terms in order to get down to 5 separate terms. Where it comes harder is when we start adding in extra operations here, like subtraction. I have subtraction because it's extremely essential that you know how to properly do subtraction. Before we do that, we do our order of operations. We do multiplication. This is a multiplication. This is a multiplication. We do multiplication before we do subtraction. And here's the essential bit. You are subtracting all of this, which means you have to subtract your entire answer here. Now there's 2 ways of doing it, and I'll show you both ways. At the same time, you have to be conscious of the fact that, yeah, we still need to distribute things properly. Now I'm going to put my red brackets here so I can continue on unphased. X by x squared, x by negative 3x, x by 9. Distribute my 3 in, 3 by x squared, 3 by negative 3x, and 3 by 9. Finish off my bracket. So the easiest way to deal with things, sorry, 1 second. Combine the terms that you can. So for example, in my red brackets, I have to combine the things that I can. No, I'm going to leave them as red. There are no other x cubes. Fantastic. But if I have my negative 3x squared and my positive 3x squareds, well, those are gone. There's nothing left. Same thing with a positive 9x and a negative 9x. Those are also gone. I'm just left with a positive 27. So I said I would show you this 2 different ways, and I will. I'm just going to rewrite the exact same work over here. So the 2 methods, one is dealing with it as subtraction and one's dealing with it as a multiplication. Because we've been doing some multiplication, might as well start with multiplication. This subtraction out in front of here, this subtraction that's in front of this entire thing, is like a negative 1 in front, which means I can technically take a negative 1 and distribute it inside these brackets. Now these are actual brackets, they're not actually parentheses, which means I'm going to have a negative or a positive x cubed, adding my x squared, adding my x, and subtracting my x cubed, subtracting 27. From there, I can do the last bit of my work. X cubed subtracting x cubed is gone. Bit of x squared, adding x, subtracting 27. The other way you can do it, which is just as fast and just as easy, well, probably, it depends on how your brain actually thinks, but you have to make sure you are subtracting every single term after a subtraction sign. X cubed subtracting x cubed. Well, that's gone. There are no other. If I did have an x squared, I have to take my x squared, subtracting whatever x squared is inside there. But just because I've subtracted this x cubed doesn't mean that the subtraction is gone. You don't write positive 27. You are still subtracting 27. There are ways to do it. You have to know your method. Last step is kind of a personal pet peeve of mine. And I'll equate it to probably the example that I use the most is 2 times 3 times 5. Well, if you're going to do order of operations, you go from left to right. 2 times 3, 6, and 30. What some people will think of doing, just because we've done a whole bunch of distribution, what some people will try and do is do the same thing, but wrong. They'll take 2 times a 5 and the 2 times a 3. 2 times 3 is 6, 2 times 5 is 10, and somehow get an answer of 60, which obviously is wrong. 30 is our only answer. Multiplication goes from left to right. You take one thing, multiply it by the thing right beside it. Yes, I know we could rearrange this. I could take 2 times 5, but then I'm only multiplying it by 3. I could take the 3 times 5 is 15, but then I'm only multiplying it by 2. You could do the exact same thing in something like this. So if you do have a 3 term, I'm going to take this entire term here, multiply by everything here. I'm going to leave this until last. So when I distribute correctly, I have to go from my left to my right, and I do things in proper order. I'm just going to save my work a little bit because I can take and simplify this before I go any further. And then from there, I properly do my distribution again. Notice how I've taken my entire answer to this binomial by binomial. I've taken my answer, then I multiply by my last polynomial, which is, in this case, a trinomial. 6 by 5 is 30. X to the power of 4. Subtracting 24. X cubed. Adding 18x squared. Negative 5 by 5, there's a negative 25. X cubed. 20x squared. And a negative 15x. And finally, my negative 4n. To get a negative 20x squared, positive 16x, and a negative 12. Combining the like terms that I can, x cubes can be combined, x squareds can be combined, and x terms can be combined. So my 30x to the power 4, my negative 24x cubed, and my negative 25x cubed be a negative 49x cubed. 18 and 20 is 38, subtracting 20. So 18x squared. I go to my x terms, negative 15 and positive 16 would be a positive 1x. You can write the 1, you don't have to. Negative 12 at the end. And there's our multiplication. A lot of stuff, at the same time, quite an essential skill. Go have fun.